So today we have a question with us, yeah? Um, so the question goes like this. You have a bullet of 100 grams, and it's moving in an unknown initial velocity, and it comes and collides first with a 3 kg block. When it collides with a 3 kg block, it causes the 3 kg block to move at a velocity of 2 meters per second. And then after its collision with the 3 kg block, it passes through the 3 kg block, as you can see here. And then when it passes through the 3 kg block, it comes and collides with the 5.4 kg block. When it collides with the 5.4 kg block, it causes the 5.4 kg block to move at 6 meters per second. But unlike the 3 kg block, it doesn't pass through it. It actually just gets embedded, right? It stays within the 3 kg block throughout the collision. So our task here is to actually come and say, okay, what is the speed from A to B, so at this point? And it's quite easy for you to go about. Well, not easy, right? This is actually a hard question, and I would actually like to consider it as one of the hardest questions that you're going to be getting in terms of momentum and impulse. And considering the questions that I've given you thus far, I would definitely consider it a very hard question. So yeah, looking forward. Um, what I would guess is that your initial train of thought would be, let me try and find this, velocity from A to B, considering 3 kg block, because that's the first collision that happens. So when you do that, what actually goes on? You first of all remember, always start with this. You see this? You have to mention which direction you're choosing as positive, right? And then, okay, sure. Let's look at the first collision. We write down the mass of the block, the mass of the bullet, the velocity of the block. It was stationary, henceforth it's zero, its initial velocity. Initial velocity of the bullet, that's what we're going to be asked to find in 1.2. And then the final velocity of the bullet is unknown. So this final velocity after collision with the 3 kg block, it's unknown, and the final velocity of the block itself is actually known to be 2 meters per second. So here you have two unknowns. So if you place it in this equation, that was not going to work. So this just tells you that you're supposed to be using a separate block for you to find this. So your separate block is the one for 5.4 kg. So okay, sure. Let's write down the components of the 5.4 kg block. So its mass 5.4 kg. The mass of this one 0.1 kg. The initial velocity of the 5.4 kg is the same for the previous one, it's 0 because it was stationary. The final velocity is 6, right? As given over here. And then, well, the initial velocity of the block, that would be the velocity with which the initial velocity of the bullet, that would be the velocity with which the bullet left the 3 kg block. Why is that? Because during this point in time, see this middle point, we consider it as being, you know, since it's an athletic system and there's no other force that's going to be acting on the bullet, that's generally what we're thinking. There's no air friction, and usually you are never gonna get a question with air friction in grade 12 or in your high school ever. Impossible, right? So considering that fact, let's just say highly unlikely. I don't know where you guys go to school, but that is the situation. So given that particular fact, um, this means that this initial velocity, well, yeah, this initial velocity of the bullet with looking to the second collision would have been the final velocity from the collision with the 3 kg block. Keep that in mind, right? So that means that this and this, same thing, right? Now, what about the final velocity of the block? Well, we are told that the bullet becomes embedded when it collides with the 5.4 kg block. Henceforth, if it becomes embedded, it's similar to the previous question, the previous video that I showed you, which is the one for the ball falling on top of a trolley and it stays in the trolley. Henceforth, throughout that motion, the ball now maintains the same velocity as the trolley. Henceforth, in this instance, you would be having the same kind of appreciation of the question. So given that particular fact, we come and answer. So that means that you have to use the second collision for you to be able to find the answer, right? So your final, we have written the initial velocity here for the bullet for this collision. We don't really know it. It's v. We already has v, right? Uh, Now the initial velocity of the block, we know that it's zero. Henceforth, all of this is going to be zero. You don't really need to write whatever it is that you would be thinking about writing, which is to write the mass and the velocity and work it out. It's just going to be very frustrating. You don't want to do that. So we look into this one as well. Well, in terms of the final, you have 0.1 in terms of the mass, didn't change. Final velocity for the bullet, we don't really know what's going on there. Or do we? Now we actually do know. It's this, right? It's the 6 meters per second, right? Because why again? Because it becomes embedded, henceforth they move in the same velocity. So you come and write your 6 here, and you say plus what's the mass for the thing? It's 5.4 and at the same velocity. So calculations, you would be having 0.1 v is equals to what? Let me get out my calculator. That would be 0.1 multiplied by 6, most likely 0.06. I'm just guessing. Yeah, no, 0.6. Yeah, that's fine. Plus 5.4 multiplied by 6 gives you 33. Right. So you divide both sides by 0.1. You don't necessarily have to do this step of division, but yeah, and your answer is going to be 330 meters per second, right? So 230 meters per second. So if you found this, if you found this, right, the the initial velocity for this point, that means that you also found this, right? So it's therefore quite easy for you to be able to find the answer to the second one, because all you have to do is just come and, you know, insert this into the question and henceforth find your answers. Like to do the same process, m1 v1 initial. This is initial, not final. This looks like final and it's not. And then m2 v2 initial is equals to m1 v1 final plus m2 v2 final. Right, what's going on? What is your mass? Your mass is 0.1. What is your initial velocity? Well, that's what we're trying to find. Let's just write vi, it's fine. Yeah, let's write v1i, or you can say vi1, whatever annotation you want to use. And then the mass of the block is 3. What about the velocity? It's 0. And in terms of the second part, well, what's going to go on here? So here they're not going to have the same velocity, quite evident. The final velocity for the block was 2, and the final velocity at this point, as we calculated, was 330. Henceforth, you're going to be having yourself 3 multiplying 330 plus, oh, not 3, sorry about that, that's going to be 0.1, mass of the bullet, plus 3 multiplying 2. Quite underwhelming, but yes. You'll be having 0.1 v1i is equals to what? Well, you're multiplying 0.1 with this, henceforth you're going to be getting 33 plus what? Plus 6. How much is that? It's going to give you 9. So it's 0.1 vi, or v1i is going to be equals to 39. You divide both sides by 0.1 unnecessarily, so I just do it because I guess, I don't know, I want to make life easy. And you get a initial velocity of 290 meters per second. To the right, now they said speed, so you don't really have to write direction, right? Speed is for magnitude, it's a scalar quantity. So yeah, that is the situation. Hopefully this made it easy, and also this makes sense that this would be much greater, well, to a certain extent greater than this one, because this was before the collision, right? And henceforth it was needed for it to be able to be pushed towards the other one. So this is your answer. I hope that this helps.